Welcome to the unit on graphs and transformations. In this unit, we will be looking at key concepts through review exercises. The objectives for this session are to review previous topics through exercises, namely factorizing quadratic expressions, sketching graphs of quadratics, sketching graphs of cubics, solving simultaneous linear equations. Pause the video and have a go at these review exercises. When you are ready to view the solutions, press play. In review exercise 1, we are required to factorize quadratics, which are of the form ax squared plus bx plus c, and a, b and c are real numbers and a does not equal 0. Let's take a look at one factorizing method. So suppose ax squared plus bx plus c equals 0. Then we use the quadratic formula to solve this. X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. This formula is either going to give two real values, or one repeated value, or no real values. So let's have a look at the first exercise, exercise 1a. We are required to factorize x squared minus 7x plus 12. We apply the quadratic formula as shown. A equals 1 has been plugged in. And now b equals 7 is shown. And finally c equals 12 is shown. Next we tidy up. The minus 7 squared in the square root becomes 49. Minus 4 times 1 times 12 becomes minus 48. 2 times 1 is 2. And then the bit in the square root is tidied up also to give 1. So either x equals 7 plus 1 all over 2, or x equals 7 minus 1 all over 2. And of course 7 plus 1 all over 2 is equal to 4, and 7 minus 1 all over 2 is equal to 3, as shown. And therefore x equals 3 or x equals 4. So we can factorize x squared minus 7x plus 12 as x minus 3 times x minus 4. And we have two real values or two real roots. We will now take a look at another factorizing method, and we will use it to solve exercise 1b. So the first stage is to find two factors of AC in our quadratic ax squared plus bx plus c, which add up to b. Next, we rewrite b as a sum of these two factors, and then factorize each pair of terms, and finally take out the common factor. So let's solve review exercise 1b. Using this method. Now factors of AC equals 12 are 1 times 12, 2 times 6, 3 times 4, minus 1 times minus 12, minus 2 times minus 6, and minus 3 times minus 4. So which of these factors add up to b equals minus 7? Only minus 3 and minus 4 satisfy this property. So let's rewrite x squared minus 7x plus 12 as x squared minus 3x minus 4x plus 12. And then factorize each pair of terms as shown. So x squared minus 3x becomes x times x minus 3. And similarly, minus 4x plus 12 becomes minus 4 times x minus 3. Take out the common factor, which is x minus 3, and x minus 4 is what remains. Review exercise 2 requires us to sketch quadratics. So what do we need to sketch a quadratic? Firstly, we need to find the intersection with the y-axis. Then we need to find the intersection or intersections with the x-axis. And we need to find the turning point at minus pq when f of x is expressed as a times x plus p all squared plus q. And finally, we identify and label these points and label the axes, then join the points to form a smooth curve. So what does review exercise 2a ask us to do? We are required to sketch the graph of f of x equals x squared minus 6x plus 2, where x is a variable in the real numbers. So firstly, let's find the intersection with the y-axis. When x is 0, what is y? We plug in x equals 0 into our equation, as shown, to give y equals 2. Next in the process, we ask the question, when y is 0, what is the value of x? So we plug in f of x equals 0 into the equation to give x squared minus 6x plus 2 equals 0, and then we solve. Here we're going to solve this using the quadratic formula and plug in minus b, and then b squared, and 4ac, as shown, all over 2a. We tidy up, and we're left with x equals 3 plus or minus root 7. So we have two intersection points. So when y equals 0, x equals 3 plus root 7, or x equals 3 minus root 7. Now for the turning point. We express y in the form x minus 3 all squared minus 9 plus 2. This is equal to x minus 3 all squared minus 7. So the turning point is at x equals 3, y equals minus 7. Let's now plot these points. 0, 2 goes here. The intersection point 3 minus root 7, 0 goes here. 3 plus root 7, 0 goes here. And the turning point 3 minus 7 goes here. Now for review exercise 2b. Again, we use a similar method. When x is 0, what is y? We've plugged in x equals 0 into our equation to give y equals 5. So when x is 0, y is 5. Next, we ask the question, when y is 0, what is x? So substituting gives us minus x squared plus 4x plus 5 equals 0. Then, using the method of completing the square, as in exercise 2a, we obtain that minus x squared plus 4x plus 5 equals 0 is equivalent to minus x minus 2 all squared plus 4 plus 5 equals 0. And then tidying up, and rearranging, then square rooting and rearranging again to give x equals 5 or x equals minus 1. And finally, for the turning point, we can express y as minus x minus 2 all squared plus 9 using the completing the square method. This gives us that the turning point is equal to 2, 9, as shown. So we can now sketch the graph. 0, 5 is here, 5, 0 is here, minus 1, 0 is here, and the turning point, 2, 9, is here. And now for review exercise 3. We are required to copy and complete the table of values for the function y equals x cubed plus 2x minus 3. There are 5 values which are missing for y in our table. Once we've plugged those in, we are required for part B to use this table of values to draw the graph of x cubed plus 2x minus 3. So let's have a go at part A. When x equals minus 2, y is equal to minus 2 cubed plus 2 times minus 2 minus 3. Here, of course, we've simply plugged in x equals minus 2 into our equation. And then we tidy up to get y equals minus 15. And then we plug this into our table. Similarly, when x equals minus 0.5, we plug in x equals minus 0.5 into our equation. As shown, to give y equals minus 4.125. Similarly, for x equals 0, to give y equals minus 3. And for x equals 1, we plug in x equals 1 into our equation to give y equals 0. And finally, for x equals 1.5. Plugging in x equals 1.5 gives us 3.375. So plotting these gives us the graph shown. This is minus 2, minus 15. And so on throughout the graph. And finally, joining the points gives us the graph shown. We will now proceed to solve review exercise 4a. Before we do this, let's explore the steps we need to take. So in order to solve simultaneous linear equations, we either make the coefficients of x the same or the coefficients of y the same. Then subtract the equations to eliminate x or y. Find the uneliminated variable and then substitute into one of the original equations to find the eliminated variable. And finally, check the values of x and y in the other equation. So let's solve review exercise 4a. We are required to find the point of intersection of the following equations using elimination. Y equals 3x minus 4 and 3y equals 2x minus 19. So remember that we are either required to make the coefficients of x the same or the coefficients of y the same. So we will proceed to make the coefficients of y the same. If we multiply equation 1 by 3, we obtain 3y equals 9x minus 12. Next, we subtract equation 2 from the new equation 1 dash. To give 3y minus 3y equals 0y, 9x minus 2x equals 7x, minus 12 minus minus 19 is 7. Next, we find the uneliminated variable. Rearranging gives us 7x equals minus 7. And dividing both sides by 7 gives x equals minus 1. Finally, we substitute x equals minus 1 in equation 1. To obtain y equals minus 7, as shown. And finally, we check the values of x and y in the other equation. So we substitute x equals minus 1 and y equals minus 7 in equation 2. To give 3 times minus 7 equals 2 times minus 1 minus 19. And this is indeed correct, as the left-hand side equals the right-hand side equals minus 21. So x equals minus 1 and y equals minus 7 are the correct solutions for these equations. Now let's have a go to review exercise 4b. This time we're required to solve the two equations using substitution. So what are the steps required? First, rearrange one equation so that one unknown is the subject of the equation. Next, substitute in the second equation. Then substitute to find the second unknown. And finally, check by substituting the x and y values in the equations. So let's solve exercise 4b. We rearrange the first equation to give 3x equals 3 plus y. 3x comes from here, and as we're adding y to both sides, we have 3 plus y on the right-hand side, as shown. Rearrange to give y equals 3x minus 3. We've simply subtracted 3 from both sides, as shown. Next, substitute the new equation 1 dash in equation 2. So equation 2 was 5x plus 2 times y equals 16, and where we have the y, we substitute 3x minus 3, as shown. Rearranging and expanding the brackets gives 2 times 3x is 6x, and 2 times minus 3 is minus 6. And tidying up gives 5x plus 6x is 11x, and 16 plus 6 is 22. And finally, dividing through by 11 gives us x equals 2, as shown. Now let's substitute x equals 2 in equation 1 dash to find y. Substituting x equals 2 gives us y equals 3 times 2 minus 3 to give y equals 3. Therefore, the solution is x equals 2 and y equals 3. For the final stage, let's double check that the solution is correct. So we substitute in the equations. Substituting x equals 2 in equation 1 and y equals 3 also in equation 1 gives us that the left-hand side is 3 and the right-hand side is 3 anyway. Now let's substitute x equals 2 and y equals 3 in equation 2. The left-hand side is 16 and the right-hand side is 16 anyway. So therefore the solution satisfies the second equation also. So x equals 2 and y equals 3 is the correct solution for this pair of equations. So this brings us to the end of this session. If you have understood its contents, you should be able to factor quadratic expressions, sketch graphs of quadratics, sketch graphs of cubics, solve simultaneous linear equations, and solve simultaneous linear and quadratic equations. Thank you very much for listening.